Please open in your learning workbook to page 202 and read along as we learn together. As a final exercise in this section, we return to a previously learned topic, finding domain from an equation. By now, I hope you know the following structure for finding domain. Step 1, start with all real numbers. Step 2, if you have any even index radicals, then set the radicand to be greater than or equal to 0. Step 3, any log argument must be greater than 0. Step 4, any denominator must be not equal to 0. Up until this point of the semester, we've been able to ignore step 3 because we hadn't learned logarithms yet. But now that we've learned logarithms, we can incorporate step 3 into our 4-step process. Let's look at an example. Write the domain in interval notation. F of x equals log base 2 of the sum 2x plus 4. All right, we go through the 4 steps. We start with all real numbers. There are no even index radicals, so we skip step 2. There is a log argument for the first time. 2x plus 4 must be greater than 0. So we take the 2x plus 4 and we set it to be greater than 0 and solve for x. Subtracting 4 on both sides gives us 2x is greater than 4. Dividing by 2 on both sides gives us x is greater than 2. So our domain is negative 2 to infinity. The reason why we don't have to do step 4 is because we don't have any denominators for this particular function. So parenthesis negative 2 comma infinity and parenthesis is our final answer. Let's look at part B. G of x equals the natural log of the difference 5 minus x. We go through the 4 steps. Once again, we start with all real numbers. Once again, there are no even index radicals or denominators, so we only have to focus on step 3. Set the log argument to be greater than 0. So we have 5 minus x is greater than 0. Subtract 5 on both sides, we get negative x is greater than negative 5. Divide by negative 1 on both sides, and don't forget to reverse the inequality sign, gives us x is less than 5. So our domain is parenthesis negative infinity comma 5 close parenthesis. All right, one more. H of x equals log of x squared minus 9. For the 3rd time in a row, there are no even index radicals or denominators, so we only need to focus on the log argument and make sure that it's greater than 0. So x squared minus 9 has to be greater than 0. Moving the 9 to the other side gives us this inequality statement. X squared is greater than 9. In our previous video, we learned what has to be true so that when you square a number, the result is bigger than 9. We learned that x would have to be bigger than 3 or less than negative 3. And this gives us this interval, parenthesis negative infinity comma negative 3, close parenthesis, union parenthesis 3 comma infinity close parenthesis.